All right, let's get started. Well, good morning, good afternoon, and good evening. Wherever you are today, hello and welcome. My name is Pang Sang-Ka, or just Pang. For our attendees who knew me when I was the CEO of Transformix before ATS acquired the Symphoni intellectual property, I'm excited that this transformative technology is now backed by a global automation company with global support and services. I'm your host for this webinar today. If the virtual tour appears slow on your computer, no worries. We will be sending you a recording of this event. And before we start, just a couple of housekeeping. To protect everyone's privacy, we have turned off the chat feature of the webinar and we have muted everyone. That means that you will not be able to communicate with any attendees nor see who they are if they chose to sign in as anonymous. I am so pumped, and I hope you are too, to introduce two outstanding individuals who has been in the assembly automation industry with a combined experiences of over 60 years. Andy Glasser is ATS Global VP of Sales. Andy, you want to wave to us? It has been with ATS for over 7 years. For more than 27 years, Andy has been involved in identifying and implementing automated manufacturing processes. Andy is passionate about manufacturing and how automation can increase productivity and lower manufacturing costs for his customers. Andy has authored numerous articles and works on these topics. Andy resides in Cincinnati, Ohio. And since he's not busy enough as our global VP and writing about automation, he is the founder of cincyrecovery.org, a community-based approach to delivering fitness to people in recovery. Larry Allingham, wave your hand, Larry, to say hello to everybody. He joined ATS as a key account manager in 2018 after ATS acquired the IP. Larry served in leadership role at Prodell and Langell. This young man with 33 years of high-speed and flexible automation experience is a resident of Chicago, who is happily married and a proud grandpa to two adorable grandkids. Andy, over to you.
Thank you, Pang. Appreciate the audience putting up with a couple of slides from me before we get to the real meat of this presentation and virtual tour with Larry. So, Pang, if we could get to that first slide. Thank you. So, titled Evolution of Symphoni Technology. It's a pleasure to be here, and I have to say I'm very excited for this virtual tour of Symphoni. This is an excellent opportunity to really understand the technology and see not just what it can do, but how it does what it does. So as Pang mentioned, I'm Andy Glaser. I've been with ATS now for a number of years. I was first introduced to Symphoni in 2019. At that time, the technology was mature, had already gone through several generations of enhancements. And it took me some time at first to appreciate what Symphoni was all about, because the technology had come so far. But what helped me to realize its groundbreaking potential was learning the history of Symphoni which is kind of correlated on this slide, and how it can be applied in solving high-speed manufacturing assembly problems. So in 2012, a Canadian company called Transformix had been building custom continuous motion machines for many years. Then they faced a new challenge that couldn't be addressed with old methods, and it involved a sugarcane seed application and the variation of weather and climate. And as we see time and time again in innovation, obstacles can liberate the imagination, and that's exactly what happened. So Pang and her team of engineers devised a solution called RSM, which you'll hear a lot of today, or rapid speed matching. It's a technological leap that they patented, and which quickly formed the foundation of Symphoni. Once that core breakthrough was established, the approach to high-speed automated assembly utilizing Symphoni technology created a whole new approach as compared to traditional methods in the automated assembly space. So over the next few years, Symphoni incorporated high-speed pick-and-place engine at the core. It offers true coordinated motion system. It's software control that allows robots and devices to move faster and more efficiently than any other technology in the market. It does, and the outcomes are eliminating waste through improved communication, through the linear motion technology, through optimized path planning, and additional plug and play modules. The sum of these attributes enable automated assembly utilizing Symphoni to be adapted to even a high mix, low volume environment with relatively low changeover. Given these differentiators, by 2018, it was obvious at ATS that we had to acquire this innovation. At that time, the Transformix group had a nice global installed base, but they were a small group, and it was challenging to scale their service organization and their manufacturing capacity to meet global customer demand. With the global reach of ATS, the synergy was clear, and we saw a perfect opportunity to acquire the Transformix IP, which is now branded as Symphoni. So ATS recognized the game-changing potential of Symphoni. It's a standardized modular automated technology. It offers high performance, precision, and flexibility. In other words, a machine that didn't have to sacrifice speed for flexibility and vice versa, and a machine that offered an alternative to cumbersome, time-consuming custom solutions. The best part about Symphoni for many of our clients is the fact that you can start with just one of these modules, as you see on the slide. You can use that module, and we call it Sonata, for research and development, your clinical trials, for prototyping, before you have to go into low output or higher output. And then when you're ready to scale up, you can just simply add more modules. This inherent potential for scalability and simplicity is a big part of what ATS saw as a solution to solve current assembly problems. The Symphoni asset is completely deployable, and that is a game changer. We also saw a far more specific synergy, a way to incorporate our SuperTrack conveyance technology and our Illuminate smart manufacturing software. These technologies significantly build on the core premise and make Symphoni the complete package it is today for anyone in the med device assembly business. So what does all this give you? In short, Symphoni provides the lowest total cost of ownership because of its standardization, modularity, ease of use, and low maintenance. Symphoni improves product quality because of its gentle part handling with friction-free orientation. Symphoni reclaims expensive floor space because of its reconfigurability, as well as its ability to be continually redeployed throughout its life. Symphoni optimizes your assembly equipment due to its operational flexibility and quick changeover. Thus, the core Symphoni DNA made up from these attributes is why there is now a totally different approach to how high-speed assembly can be automated. Faster time to market, reduced capital investment, and a lower overall price per part translates to a big advantage for manufacturers. In 2018, when ATS acquired the Symphoni IP and joined the journey of this technology, our CEO, Andrew Hyder, said that it was to develop market-leading solutions. With today's generation of Symphoni, we have already demonstrated with real customer projects, we are leading. Now it's time to see for yourselves and what I'm talking about. So now I'd like to introduce Larry Allingham, Key Account Manager for ATS.
Thank you, Andy. So again, I'll add my thanks and appreciation to all of you for joining this tour. It's unique. We haven't done something like this before, so hopefully it'll give you a good overview of what this technology is all about. So what I'm going to do is kind of first orient you as to what it is that we're going to take a look at and also where it's located. So as you can see on the screen, we've got a Symphoni machine or Symphoni cell, if you'd like to call it that. And this is located at our Innovation Center at ATS in Cambridge, Ontario. So I'll just do a little bit of a scroll here so that you can see how the machine is situated in our Innovation Center, where we're featuring as well as Symphoni other examples of ATS technology. So before we plunge into details of the machine, I'll just make a few introductory comments to kind of give you reiterate on some of the points that Andy mentioned and that Peng mentioned in the lead up. So again, Symphoni is the technology. It's designed kind of a unique combination of high speed and flexible assembly automation. and it's packaged in a modular format, which gives it configurability and reconfigurability, meaning that it's effectively serving as a long-lived asset that can be repeatedly retooled for different applications if need be. So first, to kind of just orient you a little bit into what you're looking at here, as we've mentioned a couple of times, Symphoni is modular in nature. And this small cell that we have that we're going to use as our walkthrough this afternoon is certainly an example of that. So you'll notice that there are, this basically corresponds where I'm taking my cursor here to a module or a working module. We have two working modules on this side of the machine, two working modules on the back side of the machine, which we'll see a little bit later. And then two other modules that are on the end that we typically refer to as end caps. One module that receives the main power, electrical power and pneumatic for distribution through the whole system. And the other module that houses the electronics that control the SuperTrack conveyance, which is the basis of the transport mechanism for moving work in process through a Symphoni system. So to kind of give you a sense of scale, each module or each working module is 1 meter in width. So that kind of gives you a little sense for what the size of what we're talking about here. And you'll notice that within each module, there is mounted above it an electrical cabinet. The electrical cabinet serves to house all of the controls associated for the local control of the automation that's resident at that particular module. So in other words, the control is decentralized, yet integrated in a centralized fashion, which you'll see momentarily, to allow the system, when it is running, to operate in a fully synchronous fashion. So I'll zoom in a little bit and give you a little bit closer view of what we're going to be touring through here. So the demo unit that we have is basically consists of 4 assembly stations. We're assembling a dummy product. Basically, we're assembling and disassembling repeatedly a simple 2-piece assembly, but an assembly nevertheless, or a product nevertheless, that allows us to showcase some of Symphoni's operating features. As I mentioned, the backbone of the system, or the transport mechanism, Symphoni being palletized technology, is the ATS SuperTrack. We'll take a look at that in some more detail here momentarily. And you'll see that the workstations consist of a series of robotic stations where we have these Delta robots that are mounted effectively from above, again, resident in each individual module. So I'm going to zoom in here, open up this door, and take a walk in and allow us to explore a little bit more deeply what we have. So I've mentioned a couple of times the SuperTrack conveyance. Just a few words about SuperTrack. As Andy mentioned, that was one of the additions that have been made to Symphoni technology since ATS acquired it. Basically, using this long-running flagship product of ATS that's been in operation for 20 years or so as the basis of moving materials through the system. So SuperTrack is a linear motion conveyor, which basically means that the pallets in the system are moved electromagnetically. So that gives very high speed capability for the pallets with precise control of their accelerations, decelerations, and positioning. And we're able to stop pallets at any point along the SuperTrack without requiring lift and locate mechanisms or any other type of external stopping or positioning mechanism. So it gives a lot of flexibility, very clean, low wear, high speed operation. So I'm going to click this link here and allow you to take a look of a SuperTrack system or a Symphoni system with SuperTrack in operation. It's not this machine, the demo machine, it's a production machine as it was being readied for a factory acceptance test at ATS recently. And you'll see, I'll let this video run through a couple of times, but you can see SuperTrack pallets moving freely, positioning themselves at different points. Again, accelerating, decelerating rapidly to precise positions. And you'll see repeatedly as we go through our demo this afternoon that when SuperTrack is integrated into a Symphoni system, effectively what happens is we're able to take advantage of the high-speed positional accuracy of the SuperTrack pallet, synchronized with the motions of the high-speed Symphoni robots, such that pallets spend the bare minimum time necessary in each individual workstation to allow the operation to take place. So returning to the demo again, to the unit that we're focusing on, we'll take a look first at this particular station, which is kind of characteristic of what you'll see in throughout Symphoni applications. It's what we refer to as a pick and place station. Sometimes we call it a pick and place engine. But basically what it consists of is this high-speed Delta robot. Talk about that a little bit more momentarily, but as I mentioned before, it's mounted from the ceiling of the system. And what the robot does is it interfaces with this device, which is what we call an RSM disk, or rapid speed matching disk. Andy mentioned that technology or mentioned that term in his lead up, rapid speed matching. And you'll see what this really does when I start playing a couple of videos for you. But effectively what the RSM does is it serves as the intermediary between the robot, the pallet, and an external feed system for parts being delivered into the system. Now, in this particular demo, we don't have an external feed systems. We're basically recirculating parts from one station to the next. So the actual input to this particular station is coming in from a disk just upstream of that. And you'll see this in a video momentarily. But what the RSM disk does is it captures parts as they come in. It's under control of a rotary servo, which progressively indexes the parts around. As in this particular case, when the parts are delivered in with random radial orientation and need to be radially oriented, what we'll do is we'll position those parts in the disk underneath a camera so that we can detect their orientation. And then the robot will pick those parts up. In this case, when orientation is required, you'll see that the robot is equipped with rotary servos so that the end effectors can rotate the part to the correct orientation and then place on the pallet. So let me just run a video so I can see what this actually looks like in real life, this particular station in operation. And what this also does is very clearly indicate, again, what is unique about Symphoni, because as you're seeing, as I let this video run repeatedly, high speed pick and place operation. Parts coming in, the parts can come in random radial orientation. Our camera takes a picture of the part. The robot with its rotary end effectors picks the parts out of the disk during the transfer to the pallet, corrects the radial orientation, places them on the pallet. And again, with SuperTrack's high-speed capability and precision positioning capability, you can see that a very minimal amount of time that the pallet is actually in the station, and that the operations are basically carried out in such that we already have the parts in hand in the robot as the pallet arrives. So really eliminating all of the non-value added waste that typically occurs in an assembly system, a palletized assembly system in particular, where you're waiting for a pallet to come in, waiting for a signal to say, okay, I can start my operation, carry out the operation, and then move on. In Symphoni, everything is effectively electronically cammed together, all motions in the system. in such a way that we have complete synchronous operation, as if everything were mechanically geared, as if every single motion were on you know, a line shaft. But it's digital and configurable and flexible, which is what gives it its unique power. So we'll jump in a little bit deeper here. Again, just kind of taking a quick tour around to see some of the other stations that are in the demo and point out some other features of the Symphoni technology. So the station that we just took a look at is this one right over here. We saw it from the view on the outside. This was the station just upstream of that that's delivering the parts to this particular station for orientation and placement. But taking a look here, we can kind of get a little bit better view of what's going on with these robots, which are mounted at various stations around the unit. So just a little bit of background on the you know, why is it that we have a customized a robot as part of the Symphoni system? And there's a couple of reasons for that. It wasn't the original intent when we were developing the technology. We thought maybe we could use standard off-the-shelf robots, particularly high-speed deltas, to do to be serving as the basis for our operations. But we quickly discovered that you know, because of communication requirements with external controllers and things of that nature, there's we couldn't get the throughput that we wanted to achieve with Symphoni, with off-the-shelf robots, and furthermore, we needed to have the ability to do some pretty significant force-bearing operations that are characteristic of most assembly applications. And typical Delta robots that are commercially available just aren't designed for that. They don't have the strength in their linkages to permit those types of high force applications. So we ended up developing a robot that meets the needs of the application. That is, it gives us the opportunity to move very, very quickly. The robot has been designed and optimized through finite element analysis to get as much mass out of the unit as possible, while preserving the strength necessary, the necessary to carry out the operations, but with as much mass removed so that we can move quickly. And we're moving quickly in a very narrow band. We're just moving basically between the disc and the pallet. So we have a relatively short stroke in, let's call it the Y direction, and we also have positional capability in the Z location as well. And then if we, depending on the type of end effectors that we place on the end of arm tooling, you see different examples of that. We'll see more as we go through. You know, we can carry out you know, additional servo-based operations, whether it's inversions or radial orientations or what have you. Go down to this end of the system, and hopefully I won't make you too dizzy here by kind of spinning around slowly and taking a look at the system from this particular perspective, and zoom in a little bit here and kind of see some examples of different types of end effectors. This end effector here, again, everything above the base, above the end of arm tooling is completely standard. The end of arm tooling is first configurable with what we call a deck, and then part specific touch tooling that's added to the deck to allow us to actually carry out you know, different types of operations. This end of arm tool is designed to do an inversion operation to rotate a part 180 degrees. And then, as we've seen before, we have end effectors that can be equipped with rotary servos to do radial orientation. Again. So just to allow you to see a couple of other videos here to give some examples. Again, same demo unit This particular station is doing a disassembly operation of a second part that has been assembled, placed back onto the disc and delivered back to the previous station for loading. So just a point of note, the demos, the videos that you're seeing in the demo, we're operating obviously in a 2-up palletized environment. The output or the throughput of this system is 280 parts per minute. That's a fairly, I should say, it's far from the maximum capability of Symphoni. The Symphoni robots have been designed to stroke at a rate of up to 200 strokes per minute. Typically, we limit the stroke rate that we use in actual applications to 150 per minute, which means that at any given station, we can typically process in a 2-up environment 300 parts per minute, which again, for palletized assembly systems, now we're getting to speeds that are much more characteristic of technologies, hard tool technologies like continuous motion. So we'll leave the demo unit momentarily just to take a quick look at a couple of other smaller, if you will, 3D tours that we have of a couple of production systems. This is a medical device system, and here, or medical device assembly system. And here we actually see, what a system looks like when we've got it configured with external feed systems. So as is more typical than what we're seeing in the demo that we're walking through here today, external feed systems feeding parts into one of these RSM discs, which are then captured, oriented if necessary, or checked for orientation if necessary, and then the robot makes the placement to the pallet. This particular system, I think, has a total of 4 working modules associated with it. We have another one that I will show here that's a little bit larger, with 6 modules. But again, you can get an appreciation, I think, for what you're seeing here in terms of the very high level of standardization. So completely different products, different physical configurations in terms of number of modules. But again, very, very high level of standardization. Basically, what's changing at any given workstation, particularly for assembly operations like pick and place, is just going to be the disk, which happens to be specific to the part, and the touch tooling that's interacting with the part itself. And of course, pallet fixtures are going to be specific to the product as well. But the robots themselves, the control system, the overall infrastructure, very high percentage of the total investment is taken up in completely standard, configurable and reconfigurable assets. And this can become, extremely important in situations where, for example, if you're a customer that has multiple variants to your products, or multiple products that that you would typically be placing on separate machines, in many cases, those can be grouped together into one high-speed Symphoni system with quick change tooling between one product and the next, allowing you to conserve capital, conserve floor space, etc. So while we're on the topic of medical applications and real world applications, I'll let this video play. Which again, this isn't the demo unit. This is an actual production machine assembling I believe it's a 4-piece medical device. This is again taken during preparation for FAT at ATS. Here we're seeing high-speed placement of O-rings, placement of a device, or assembly of a device to the ring, or to the seal rather, assembly of a third component, assembly of a fourth component. We're operating in a 4-up environment here. I believe the output of this machine is 300 parts per minute. And this we're doing, again, taking advantage of SuperTrack's ability to rapidly stop positions. Doing what you just saw there was a series of inspection operations, doing final inspection of the assembly before it gets to the unload station. So back to the demo unit. I'm going to exit the interior of the machine. Bear with me as I spin us back around to where we can see it's right back here. So we're back to the front of the machine again. One thing that I wanted to point out as well, we've mentioned that, or I've mentioned that the system operates with decentralized plug-and-play modules, but when the system is in operation, you have a complete integrated motion of such that all motions in the system are basically electronically cammed together. So even though each module is basically controlling what's going on at its individual module, it's doing so with reference to a master cam, which in most cases is the SuperTrack palette system itself. It's kind of defining, if you will, in a 360-degree cycle, at each point in that cycle is defining and basically allowing, serving as the master cam for all other motions, for all other devices, and all other modules to be specifically referenced to that. And that allows us to do some very interesting things, which I'm going to show you by taking a look at the HMI and what's an example of not only of what's possible through the HMI, but also of how the system functions in this integrated fashion. So what you're seeing here is the operator has come over and is changing the rate at which the speed of the system operates, repeatedly toggling it back between 25 parts per minute and 280 parts per minute. The 280 parts per minute is the design rate of the demo system. 25 parts per minute is just an arbitrary number that has been, let me just back this up and let this run a little bit more, arbitrarily selected. The operator could select to run the machine at 100 parts per minute, at 150, at 1 part per minute. And regardless of the speed that's selected, you see the same integrated, synchronized motion system-wide. Again, this is a reflection of the control methodology with its electronic camming control, and then as well, with the efficiency of the system in terms of the minimization of non-value-added operations, basically eliminating waste, allowing the very high throughputs, but again, in an environment that is digital, flexible, and highly standardized. So I'm going to we're just kind of maybe conclude just by giving you a couple of more views of the system, walking you around to the backside if I am adept enough to get us there. One other thing that I'd like to point out is which you can see on the back side of the machine here, if I can get us there. And that is that in most cases, what we've seen on the demo, we've seen one robot per module, but as shown here in this particular module, we can house up to 2 robotic workstations within a given module, this being a single module, robot 1, robot 2. So again, that also enables us to kind of have a nice, densely packed, compact system that conserves floor space, and gives a very high output per square meter of floor space. Another very good feature benefit of the Symphoni technology. So with that, I've kind of given you at least what I hope is an initial high-level overview of the technology. Maybe the next best thing to being there or being in front of a real machine is seeing what we've been able to take a look at this afternoon in this very brief 3D virtual tour. Certainly, again, this is a very high-level introduction. Certainly interested in responding to any questions that you may have either now or after the webinar, and would certainly be interested in exploring in much greater technical depth some of the features and benefits and operating characteristics of the system. So this video just kind of gives other examples of sort of the precision and control that's possible with Symphoni. So just very important to show these sorts of videos, I find in my experience, because sometimes people's initial reactions when they see something operating at such high speeds is, oh my goodness, this must be very good for maybe very rough applications because it appears to be very violent and things of that nature. But when you really take a look at what's going on with high speed, as for example here where we're doing high-speed O-ring placement, in fact, things are carried out at with great precision and great control. So I think that pretty much concludes what I wanted to share with you this afternoon. It was very quick, it was very high level, but again, certainly interested in responding to any of your questions now or others that may crop up afterwards. So thank you very much for your time and attention.
Okay, question 1. What is the maximum force the robot can apply? Larry?
That's a very good question. I hesitate to give the answer. I'm not. I'm going to have to defer that and take that question to that person and get back. I don't know I think I know, but I don't want to give a number and find it to be wrong. So rather than say what I think off the top of my head the answer is, I'd rather get back to you with the real answer.
Fair enough. Question 2, is this platform already in healthcare and life science apps?
Yes, absolutely.
Okay, question 3, what is the pick and place payload?
Again, another question that I'll have to defer and get back with a specific answer to.
I'm thinking this person might want to sign up for the
Larry,
live interactive Q&A.
Hey, Larry, on the payload, though, it's several kilograms, right? I mean, it's going to be at least 1.5 kilograms to 2 kilograms, maybe even up to 3 kilograms.
Yeah, well, there's the payload is you've got the payload that includes the end of arm decks.
Right. So it's the end of arm tool and the part, but I gotta believe it's at least 1.5 kilograms.
I'm pretty sure it is, maybe even more than that, Andy. But again, I'd like to make sure.
Okay.
Another question: how quick to deploy, let's say, a 4-part assembly system?
Very interesting question, and the answer to that is in the process of changing, and I'll explain why. So one of the characteristics of Symphoni, by virtue of the fact that it's modular and it's standard, is it allows us to basically create inventories of standard items that we can deploy quickly. One of ATS's divisions is what we call our REM division, which stands for Repetitive Equipment Manufacturing. So we're in the process now of transitioning the manufacturing of Symphoni modules to our REM group, which means that we would have a very quick turnaround capability on Symphoni systems. So in terms of our ability to produce and get the base systems in place in a matter of let's say either directly from inventory or within a few short weeks after receiving a PO. That's going to dramatically reduce lead times on machines. Currently, again, it's difficult to say a 4-part assembly versus any other type of assembly, but again, the expectation is going forward as we do the transition to the REM group, that we would be looking at lead times well within 6 months for simple assemblies. And I think that's a fair statement on that, correct?
Yes, that's right, Larry. And yeah, I'm intimately involved in that whole process with the REM group, and we have launched our building up our inventory of the middle modules and the power and the control end. So the two, as Larry said, the bookend. So we will be able to build up our Symphoni equipment faster than anybody in the market, and that is the goal. So we have kicked off that process quite a few months back, actually. So that's our goal. Okay, another question. What class clean room are the cells certified for?
I don't think we have any clear certification for the equipment. They're going into, I think, what used to be class 1000, class 100 clean rooms. Again, that's I'm not sure, Peng, maybe you know more as to whether or not there's actually an effort to certify or to
There is effort to get machine FDA approval as part of that REM process, but I don't know what the certification is, so we'll get that answer to the individual who asked. Okay, another question, Larry. With decentralized modules using the electronic CAM concept, if any one of the individual modules demonstrate communication issues or lag, the entire system risks getting out of alignment. How do you prevent timing gaps between the modules in real time? Also, how do you secure that there's no diff over time?
Very good question. So again, without going into more depth than I'm really competent to go into, what I can say is that one of the characteristics of the software and the way that it works is that we're monitoring the position of every single encoder in the system, that is every single servo in the system, at a 5 millisecond interval, where we're expecting, we basically have a map of where we're expecting every device to be at each millisecond of a cycle. And if when we do our diagnostic at a 5 millisecond frequency, if we see that anything is out of place, we consider that to be an emergency and we shut the system down. So if there is something that occurs where something gets misaligned, there's something that there's whatever the issue may be, whether it's a communication problem, whether it's an electronic failure, whatever it is, if we detect that, or when we detect that, again, and we're checking this repeatedly, then we immediately shut down the system. As far as the second part of the question on what do we do with respect to any differential or difference that may occur over time, I can't answer that question with any degree of competence. So I'd have to refer that to some of our technical experts to get back with more detail.
All right, is this a PLC platform?
It is a PLC platform. That is the control system. The controls for each of the individual modules are controlled by PLCs. Currently, we're using B&R hardware. As we have, B&R hardware has been sort of the basis of AATS SuperTrack for many years. But what's important to recognize is that we've developed the operating system of Symphoni, that is the software that really manages all of this this high-speed motion, this the synchronization and coordination of multi-axis motion. That is basically platform agnostic. So although we've centered on the B&R control system as the hardware mechanism, really that's in terms of what's theoretically possible. Theoretically, we could use any type of control hardware, PLC-based control hardware. It happens to be B&R that we've gone with.
Is this CE compliant?
It is.
What is the cost difference between a Symphoni machine and a traditional synchronous or mechanically cam-driven machine? Boy, that's going to be a hard one. Depends on so many things. I'll let you answer, Larry.
It's a very interesting question. And in some cases, it's true the Symphoni comes at a premium. In other cases, surprisingly, Symphoni becomes a lower cost alternative. And I'll explain why. Symphoni has a very high level of standardization. So you spend, there's a lot of investment, if you will, in hardware, in standard hardware. We've got a decentralized control structure, so you've got a lot of electronics. So that's where you have that cost threshold just kind of built into the inherent structure of the system. But since you have a very highly standardized platform, typically the engineering content of a machine is much lower than in a customized machine. Because really what we're doing is we're using the same software, the same platform all of the time. And we're designing end-of-arm touch tooling, designing things of that nature, which compared to starting with a blank sheet of paper each time, really minimizes the engineering cost. And as Peng said, and I said earlier too, with repetitive equipment manufacturing, we're able to really drive cost out in the assembly area as well, in the assembly of the modules themselves. And then also because of, if you take a look at two systems side by side, for example, if we say 300 parts per minute is the output, and we want to compare getting 300 parts per minute on a conventional palletized machine versus 300 parts per minute on Symphoni, in your conventional machine, you're going to have a lot more tooling. So a lot more floor space, a lot more hardware, a lot more stuff that comes at a cost. Whereas with Symphoni, you're going to have a much more compact system, typically a lot less tooling, and save cost in that respect. So again, in certain applications, we find that Symphoni is far and away a lower cost alternative, which you might not expect with a technology having such premium performance characteristics.
Again, how do you compare that when you have a fixed single-use machine that may sit in a corner gathering dust if the product doesn't take off or consumer behavior change or whatever the reason, versus a multi-purpose technology that is a depreciable asset, no different than your injection molding machine. So, there's a kind of a mind change in how you invest in Symphoni than the traditional way that you've been buying your assembly equipment. So, Larry, one final question. If I have a high volume product that has no variant, is that a good Symphoni fit?
It's worth investigating for sure, because it could be. The answer could be yes, it could be no. In some cases, a high volume standard component with no variance, it's better use, or you get better value by going to a more traditional technology. But again, in other cases, particularly for complex assemblies that may not lend themselves very well to technologies like continuous motion, if you're looking at comparing some other type of platform to Symphoni, where you've got lots and lots of tooling, where you're operating at 4 up, 6 up, 8 up, 10 up, 12 up, whatever it might be, then Symphoni can be a much better solution, just simply because of either floor space savings, increased throughput, combination of the two, or reduced cost. So it's really, Symphoni can be very broadly applied. If you have an interest in the technology, it's worth talking to us to see if it's a good fit. We have other platforms as well, other than Symphoni at ATS. So we're not interested in shoehorning you directly into this if it's not a good fit. But surprisingly, it's very broadly applicable. and definitely worth investigating, regardless of what the specific rates or characteristics might be. Worth a check, because there's a lot of benefits to be gained if it's a good fit.
So Larry, it's 2 o'clock and some of our audience may have to go, but I have one more question that just came in, so I hope you can stay and answer it. For the remaining audience, I just put up the contact information. By all means, please reach out to us if you have more questions, and if we're not the right people, we'll make sure that we find the right technical engineers to answer your questions. So final questions. Are the pick and place stroke easily changeable after deployment?
Absolutely, absolutely. First of all, there's a whole series of standard selectable profiles that give different types of motion characteristics. And then secondly, from the HMI, you can actually go in and adjust pick and place positions in 0.01 millimeter increments. So you can very definitely make changes after deployment.
Okay, well, thank you so much. Thank you, everybody, wherever you are today, for joining Larry, Andy, and myself on this journey through a virtual Symphony machine. We cannot bring the machine to you, so we hope that that's the second best option. Thank you, Larry and Andy, for being our panelists today. Have a good day, everybody, and hope to talk to you soon. Bye for now.